Continuing with the elimination method, sometimes we don't even have the same number for a variable, so that we can just make opposites easily by multiplying the bottom equation by -1, or the top equation. Sometimes you're going to need to multiply one equation, or even both equations, by a number to create opposites before you can add them together. So you're trying to make the numbers match, as well as the signs be opposite signs. So to do that, what you want to do is these three steps right here. Pick a variable to eliminate. It doesn't matter which one you want to eliminate. You can eliminate x or you can eliminate y. Doesn't matter. Usually I go with the one that seems like it's going to be easier to eliminate. Then multiply one equation by a number to make opposites in that variable that you're trying to eliminate. You may need to also multiply the other equation by a different number. We'll see that happen today before we get done with the section. Once you've created opposites, then you can add and eliminate a variable and then solve the problem as usual. So it's like one or two extra steps that you have to do here. They're not that big a deal though. You just got to think a little bit before you just plow ahead into the problem. So solve the system using elimination. Do we have opposites right now? If I add right now, do I get stuff to disappear? No. If I add -2x and 7x, I get 5x. The x does not disappear. If I add 15y and -5y, I get 10y. The y does not disappear. So if I add these right now, it doesn't do me any good. Which means I need to create opposites. So we need to pick a variable to eliminate. We can eliminate either variable, but one of them is going to be easier than the other in this case. Why the y? That's right. If I multiply the bottom equation by 3, then what I'll have is -15y right here. And this is positive 15y. And then will I add and the variable will disappear? Yes. So that's what I'm going to do. I'm going to choose to multiply the bottom equation by 3. Because that will give me opposites in y, so that I will eliminate y. So now I draw my arrow over just like we were doing before. I did not do anything to the top equation, so I just rewrite it. -2x plus 15y equals -32. I'm rewriting the top equation. Now I rewrite the bottom equation, but I distribute the 3 all the way through. So what do I get? 21x minus 15y. Notice that those are opposites, so now when I add, they'll disappear. Equals, 17 times 3 is 51. So now I have opposites right here in the y variable. So I can add these two equations together, and the y variable will disappear. So what do I get? 19x -32 plus 51 is 19. And now solve for x. What do we do? Divide both sides by 19. So x equals 1. So now that I know that x is 1, what do I do? Plug it in where? It has to go all the way back to an original equation. Whichever one looks easiest to work with is my advice. Which one looks easier? The bottom one? Okay, that's fine. So what will I write? 7 times 1. All right. So 7 times 1 is 7, minus 5y is 17. Subtract 7, that's a positive 7 that needs to disappear. So we subtract 7 from both sides and we get -5y equals 10. Divide both sides by -5 and we get y equals. That's a positive 10 divided by a -5, so we get -2. Now what? Ordered pair is what? 1 comma -2. The x-coordinate comes first, then the y-coordinate. And then what do we do? Yeah, we got to check. So it's not that big a deal to check. It'll take you like 15 seconds. 1 goes in for x, -2 goes in for y. So what does this become? Negative 2, what does this become? Negative 30. So negative 2 plus negative 30 is negative 32. So that one worked. And then what does this one become? 7. And then what does this become? That's a minus. So negative 5 times a negative 2. Negative times negative is positive. So this was 7. This is positive 10. I add them together and I do get 17. So this is the correct answer. Watch your signs when you're checking. Okay. Talk me through the next one. What should we probably do? Multiply 3 by the top one. So multiply the top equation by 3. Why? All right, so what you're saying is I can just multiply the top equation by a number and create opposites right here in y. And that number that I have to multiply by is what? 3. So, parentheses around it, multiply by 3. I don't really have room, so I got to squeeze that in there. So, 3 times that equation. What am I going to do to the bottom equation? And don't do anything to it. Leave it alone. Draw your arrow over. And what do we write? Distribute the 3 in, so we get negative 15x. Three times 6 is 18. Don't forget to distribute all the way through. A lot of people will forget that last number. It becomes 18. What about the bottom equation? Yeah, it's just the same, so you just rewrite it. 3x plus 6y equals 6. Okay, if we add now, does something disappear? Yeah, that was the whole goal. So we draw our line and add, what do we get? Equals, yeah, that's 24. Now what? Divide both sides by negative 12. Yeah, just about negative 2. Okay, now what? Plug it back into one of the two equations and you want the top one? Oh, the bottom one, okay. Why? Yeah, it looks like it might be easier. So we'll go into the bottom one. So I'm going to write what? X is negative 2, so 3 times negative 2. Yeah. Okay. Now what? Well, 3 times negative 2, what is that? Negative 6 plus 6y equals 6. Lots of 6's. Now what? Okay, add 6 to both sides and we get equals 12. Okay, now what? Divide both sides by 6. I'm kind of out of room, but what do we get for y? Y equals 2. Now what? Ordered pair is, okay, now check. So what goes in for x? And then 2 for y. So what does this top guy turn into right here? It's positive 10. What does this one turn into? So 10 minus 4. Is that a true statement? Okay. And then what does this one turn into? Negative 6, what does this one turn into? 12. So negative 6 plus 12, is that a true statement? Yeah, because we do wind up with 6. So this is the correct answer. We can put a box around it and be confident that we got it right. And then we can move on. How about this first one? Pick a variable to eliminate. Could we eliminate x? Yeah, we could. But what would we have to turn these numbers into? Because I can't just multiply this equation by a number to get 4, or negative 4. Multiply the top by 4, that turns this into 12. Multiply the bottom one by, if I multiply by just 3, then I get 12 as well. And when I add, I get 24. but I want them to turn into 0. So if I multiply the top one by 4, then I got to multiply the bottom one by -3 to make opposite signs. That's if I want to eliminate x. But what if I want to eliminate y? What number would I want to land on? 6. So I'd have to multiply the top equation by, okay, if I multiply the top equation by 3, then I have to multiply the bottom equation by -2 to make opposites. Okay, so that's how these problems work. You got to think a little bit. Once you've thought a little bit and you understand which variable you're trying to eliminate and how you're going to have to make opposites, then you can go ahead and do the problem. So which one do you want to get rid of, x or y? Y was the first one I heard, so let's get rid of y. Which means I need to multiply the top equation by what? 3. Now, that gives me 6y when I distribute it. So what do I have to multiply the bottom equation by? -2. Good. Okay, now I'm going to draw my arrow over and distribute. I'll rewrite my system of equations. What do I have for my top equation? 9x plus 6y equals 3. Don't forget to distribute all the way through. What's my bottom equation turn into? -8x minus 6y equals, yeah, -2 times -2 is +4. All right, do we have opposites somewhere? Yeah, so we can add and the y's will disappear. So we add, what do we get? 1x equals 7. So what's x equal? 7, yeah. 1x is the same as x. So x equals 7 is my first answer. I already know what x is. What do I need to do now? Go back to an original equation. Notice that I keep saying original. We can't go back to these, because if I made a mistake in multiplication here to here, and I got this as my answer, and I go back here, I will get another wrong answer, and then when I check my answers, I might not see that I made a mistake. So you want to go back to an original equation. Which one do you want to use, top or bottom? Why the top? It looks easier? Okay. What do I write? Okay, original equation. And then 3 times 7, what's that? 21 plus 2y equals 1. Now what? Subtract 21 from both sides, and what do we get? 2y equals -20. Now what? Yeah, divide both sides by 2, and we get y equals -10. Now what? Ordered pair is 7 comma -10. If you're a habitual negative sign loser, you want to break that habit. Don't lose negative signs. Now what? Yep, check it. If you've been losing negative signs along the way, you're going to get the wrong answer. So, let's see. Take the 7, plug it in for x. Take the -10, plug it in for y. What does this turn into? 21. What does this turn into? -20. If I put those together, do I get 1? Yeah. Take 7, plug it in. 4 times 7, what's that? 28. What's this one turn into? It's -30. 3 times -10, -30. So I got 28 here, -30 here. If I put those together, do I get -2? I think so. So that's our answer. That next system is solved in the same way. You can eliminate x, you can eliminate y, and it's your choice. And it's your problem. Go ahead. When you're trying to decide which variable to choose to eliminate, because you can eliminate either variable. You can eliminate x. If you try to eliminate x, what number are we trying to get to? 12. If you choose to eliminate y, what number are we trying to get to? 6. 6 is smaller than 12, which means I'm going to be multiplying smaller numbers, which is why I would choose to eliminate y. There's another reason why I would choose to eliminate y. One's already positive and the other's already negative. You already have opposite signs. So that means I'm going to be multiplying by just positive numbers out front. Okay? Because I already have the opposite signs, which makes it a little bit easier. So for me, I'm going to choose to eliminate y. But if you'd rather see me eliminate x, I can do that. No? Just choose y? Okay. So I'm choosing to eliminate y, which means that I need to get y to turn into a 6y. So for that top equation, what do I have to multiply by? 2. And for that bottom equation, since I already have opposite signs, multiply by 3. Now, as I was looking around, I saw a lot of people not doing what I'm suggesting that you do. We draw the little arrow over and rewrite the system to the right of the original system. Do that. Trust me, it pays off. That organization right there helps. If you don't do it that way, and I'm trying to check your homework or your quiz or your test, I might not be able to follow what it is that you're doing. So do it this way. So now what do we do? Yeah, just distribute. So what do we get for the top equation? 8x plus 6y. Negative 38. All right, and the bottom equation? Equals negative 30. Good. And do we have opposites? Yeah, we did make opposites, so we're ready to go. Always double check to make sure that you actually do have opposites before you add. And what do we get? 17x equals negative 68. So the big question is, if I divide both sides by 17, do I get a fraction? What do I get? X equals negative 4? Cool. All right, so now we know that x is negative 4. What do we do now? Plug it in one of the two original equations. Which one do you want to use? Bottom? All right, so I write 3 times negative 4 minus 2y equals negative 10 using the bottom equation. Minus 2y equals negative 10, so then we add 12. What do I get? Negative 2y equals 2. Y equals negative 1. Now what? The ordered pair is good. And then check. Negative 4 for x, negative 1 for y. What do we get here? Negative 16. What do we get here? Negative 3. Negative 16 plus negative 3? Negative 19. We're good. How about negative 4 here and negative 1 here? What do we get here? Negative 12. What do we get here? Positive 2. So negative 12 plus 2 is negative 10. So therefore, we have the correct answer, and we're good to move on. We have a couple more types of situations that we have to talk about here. Like in section 2 when we were doing substitution, it's possible, and really section 1 also, it's possible for you to get weird solutions, weird answers. If you get something like 0 equals 0, or 2 equals 2, or like negative 5 equals negative 5, in section 2 in substitution, what did that mean? It meant that the two equations were actually the same equation. And in that case, when the two equations are exactly the same, then you have infinitely many solutions. If you get something like 0 equals 7, or 18 equals 14, or something crazy like that, an obviously false statement, What does that mean for your two lines? It means no solution, but if I were to graph those, what would they look like? They're parallel, yeah. They don't cross. That's why there's no solution. And it's the same thing that we learned for substitution. Same results. So let's go ahead and do these two problems here and see what happens. What should I do with that first system if I want to use elimination to solve it? Okay, which variable are you trying to eliminate? Trying to eliminate y. So if we make opposites, that means that we need to multiply the bottom equation by -2 so that we can eliminate y. That's all I need to do. So multiply the bottom equation by -2, draw my arrow over. I didn't do anything to the top equation. What does the bottom equation become? -2x minus 6y equals -18. So we made opposites, and now we add. 2x minus 2x is gone. 6y minus 6y is gone. You wind up with nothing on the left-hand side. 0 equals. 18 plus -18 is also 0. So you get 0 equals 0. Which means that these are exactly the same lines when you graph them. Which means that we have infinitely many solutions. We wind up with a statement that is always true. And if it's always true, that means every ordered pair works. And if every ordered pair works, it's infinitely many solutions. How about the second system of equations? Can we add these together right now because we have opposites? Do we have opposites right now? No, we don't. We have same numbers here, but they're the same sign also. Same numbers here, but they're the same sign. So there's not opposites. So what do I need to do to make opposites here? Yeah, just multiply one of the equations by -1. So which one? You know what? Let's do the top one this time. I just feel like doing the top one. So what do I get for the top one? 2x. Okay, minus 5y equals -7. The bottom equation is unchanged. We didn't do anything to it. Plus 5y equals 12. Now I have opposites, so I add. What do I get on the left side? Yeah, the 2x minus 2x is gone. -5y plus 5y is gone. I'm left with 0 equals what? -7 plus 12 is 5. 0 equals 5. Is that true? Never. So that means that we have no solution. If I were to put these two equations in slope-intercept form, what would I see in slope-intercept form? They are parallel lines, so that would mean I would see what? The same slope, but what about the y-intercepts? Different y-intercepts. If I were to put these two equations in slope-intercept form, what would I see? The same exact equation, same slope and same y-intercept. As usual, we'll finish off this section with some story problems. Just like with the substitution section, you're going to have to define your variables and then create your system of equations and then solve the system of equations. So in this section, we're working with elimination. So we're going to try to solve these equations using elimination. So let's read the problem. It says the theater club sells a total of 101 tickets to the play. A student ticket costs $1. An adult ticket costs $2.50. They sold $164 worth of stuff. How many of each ticket was sold? That's our job. So what are our variables here? Yes, the question gives away the variables. How many of each ticket was sold? I don't know. Well, what kind of tickets did I have? I had student tickets and adult tickets. There's my variables. So I'm going to write number of student tickets and number of adult tickets. All I have to do now is pick a couple letters for those variables. What letters do you want to use? X and Y is just fine. You could use S and A, but S's look like 5s and A's look like 9s, and it gets confusing, especially when you're watching TV and trying to do your homework at the same time. So stick with X and Y here. All right, what's the next thing we need to do? Yeah, start writing equations. So we have information. The theater club sells a total of 101 tickets to the play. You only got two kinds of tickets, student tickets and adult tickets. So if I add up the number of student tickets and I add to that the number of adult tickets, what do I get? 101. So that means that I'm going to write what for my equation? The number of student tickets plus the number of adult tickets was 101 total tickets. There's your first equation. Now the second sentence says a student ticket costs $1, and then we have an adult ticket costs $2.50. We have the total sales being $164. Notice that all of that involves what unit? Dollars. So we're going to write a dollars equation. So I'm going to have an equal sign. Tell me what to write. 1x, because student tickets are $1 each, plus 250. 250 is the same as 2.5. Equals 164. Now check your equations to make sure that all the units are correct. This is number of tickets. This is number of tickets. This is number of tickets. So we have an equation that involves just numbers of tickets. Then this is money plus money equals money. This is an equation that just involves money. So we probably have these two equations correct. Now our job is just to solve the system of equations. So what could we do? I don't subtract. Multiply the top one by -1 to make opposites here. So if I multiply that top equation, I could actually multiply the bottom equation by -1 also. But if I multiply that top equation by -1, then I create opposites in x, and then I can add the two equations together and eliminate x. So I don't have room to write it off to the right, but you guys probably do. What do I get for my new system of equations? Distribute the -1 all the way through. All the signs change. Minus y equals -101. The bottom equation stays the same. X plus 2.5y equals 164. I've made opposites so I can add. What do I get? Yeah, 2.5y plus -1y is 1.5y equals 63. Okay, solve for y. What do we do? Divide by 1.5 to both sides. And this is where you probably reach for your calculator and you get y equals what? What do you get? 42. Okay, now what? Substitute back into one of the original equations. Which one do you want to substitute into? The top one for sure, because it's just x plus y equals 101. What this says is I sold 42 what? Adult tickets. So if I sold 101 total tickets, how many student tickets did I sell? Well, x plus 42 equals 101. Subtract 42 from both sides, and I get x equals what? 59. So my answer for a story problem needs to say what? No. 59 student and 42 adult tickets. So that's my answer. My answer in a story problem switches from being an ordered pair to being something that makes sense in the problem. So just remember that for the story problems. Now, should we check this? Of course we should check it. We already know that 59 plus 42 adds to be 101, so the top equation already works. The bottom equation, though, is what we really need to check. So it's $1 for every student ticket, so we got $42 there. $2.50 for every, $59 there, 59 student tickets. $2.50 for every adult ticket, so $2.50 times 42 gives us how much we got in adult money. We add those two things together. What do we get? We do get 164. So this is the correct answer. All right, I want you guys to take some time. Try to do exactly what we did on this problem for this problem. Read the problem, figure out what it is they're asking for, define your variables, write a system, solve the system. What is the first thing we need to do here? Define your variables. What are the variables? What about Adelina and Tamara? How many friends they invited? So Tamara's friends. And that's number of, and number of, is it Tamara or Tamara around here? Tamara? It doesn't really matter. I actually know people who have the same spelling and they say Tamara and Tamara. So, sure, whichever one you want. So this would be number of, this one though is Adelina. Okay, so now that we know who's who, what letters did you use? X and Y. How many of you called X Tamara? Tamara. How many of you called Y Tamara? All right, so just by majority, I'm going to go with X here and Y here. If you have them reversed, then you're still going to wind up with the same answer. You don't have to change anything. All right, we need to write a system of equations now. We have 47 friends total, so the number that Tamara invited plus the number that Adelina invited must be 47. Good. And? So Tamara invited 5 fewer friends than Adelina. If she invited 15. So if Tamara invited 15, how many did Adelina invite? 20, because she invited 5 more than the other one did. Okay? So if Tamara invited X people, how many did Adelina invite? Would it be Y plus 5 or Y minus 5? So it says Tamara invited 5 fewer friends than Adelina. So if Tamara invited X friends, to get the number of friends that Adelina invited, we'd have to add 5 to it, right? But this is X. So if I have the number of friends that Adelina invited, I would have to subtract 5 from it, if I write it like that. Or I could have gone Y equals X plus 5. So the language on that sentence is kind of weird. Now, is this a good setup for elimination? Not right now. So I got a couple options here. It doesn't say I have to use elimination. Instead of elimination, I could use what? Could use substitution here, because this one's already solved for X. And in the next section, we're going to have to decide which method is going to be the best to use. So right now, I could just use substitution. Or I could move this Y over here, and then it'd have X minus Y equals something. And then I could use elimination. Did anybody use substitution here? Did you guys all use elimination? Okay, we have one using substitution. I'm actually going to use substitution on this because I know what x is. So that means that this y, this can go in for that. X is this, which means I can substitute it there. So I'm going to write y minus 5 plus y equals 47. Then what? Combine your like terms. Y plus y is 2y minus 5 equals 47. And then what? Add 5 to both sides. And we have 2y equals 52. Divide both sides by 2 and you get y equals 26. So y was the number of Adelina's friends, 26, which means that x is the number of Tamara's friends, and that would be 21. The problem tells me that I have a total of 47 friends. 26 plus 21 is 47. The problem also tells me that Tamara invited 5 fewer friends than Adelina. Well, Tamara's friends are x, and we said x is 21, and that is 5 fewer than y, which was Adelina, which makes that statement right there true. So therefore, we have 26 for Adelina, and we have 21 for Tamara. So there's the answer to that problem. This one's tricky because of that second equation. They give you some wacky thing that you have to really decipher. So be careful when you're writing that second equation. And then when you're checking, make sure that you understand who's who. You won't understand who's who if you didn't write this down to begin with. So write that down, and then you'll be able to say, okay, Adelina had 26 and Tamara had 21, and it says Adelina had more friends. And that's what I wound up with here, so I must have done this correctly.